a lot of people that is doing the research work behind me, so I'm just the person who speaks on behalf of them. And what I want to talk to you today is basically all these unseen damages of the stroke that people with the stroke experience and their family experience, but they not really fully understand what's going on. So because one of the things, apart from stroke, there are a few things that are very obvious. If we lose the ability to walk, if we lose the ability to use our hands, that's very obvious deficits, and we can see that. If we lose our ability to speak, that's again a very obvious deficit, but there is a lot of other host of deficits that have a direct impact on our life, which we can't really see. So even if a person can walk and talk perfectly well after the stroke, there can be a lot of host of other problems. And both the patient himself, or the stroke survivor himself, and their family struggle to understand that things are not as they used to be. So what I'm going to try and do today is try to tell you how we're going to try and study them, how we're going to try and understand them, the idea of the impacts of the stroke, or how the stroke can impact your behavior and your thinking. We can help you better and give you the proper support to foster this plasticity that Brim was talking about. And I just want to say, really thank you for Brim of giving a fantastic introduction to my talk. And, and I also want to say, following Professor Ruth, I think this is a nice order of things, because Professor Ruff mostly talks about caring for stroke in the acute stages. Well, I'm going to talk about caring for stroke at the rehabilitation stage. So we're really dealing about the things that happen after, or the life after the stroke, or after the damage, and how we can live with that. So I'm going to talk about basically two big trials, or outcome of two big trials, and I'm just going to tell you the outcome of these trials. So one trial, which again Brim was talking about, it was the BUCS trial, and it was funded by the Stroke Association. And the second trial was a COGWATCH trial, which was funded by the European Union. So given that I was not sure who the audience, and I had a bit consultation with Rachel and Dr. Sisi before we started, I'm going to start from scratch. So we all know that stroke is very common, and the statistics said that if you look around you, okay, we have quite a lot of stroke survivors in the audience, more than normal, but even if you sit in a bus around you and look around you, 1 of every 6 people is likely to experience a stroke. So stroke is here. And we have to deal with it. And I think as different from cancer and different from heart diseases, people live with stroke. So that's one of the things that as a society, they seem not to fear. I mean, we're not afraid of them so much, and maybe that's why we're not giving so much money into research, into understanding how to prevent them. But as a society, because people keep living after stroke, in the long term, it's become a much bigger issue and burden on carers and friends and institutions. So we really have to pay a lot of attention to how we really try to prevent stroke, and how we really help the people who had a stroke to go back and maintain a productive and well-being. So just in a nutshell, for those who are not clinicians, what is a stroke? So like any living thing, the brain is a living thing, it needs oxygen. So no wonder there was the project about oxygen. Oxygen arrived to the cells with blood. It's just a plumbing issue. And if there is not a blood supply to the cell, they just suffocate. Lack of blood supply can come from 2 sources. Either there is a blockage, which Professor Roth was talking about, or there is a leak, which Brim was talking about. Okay? So it's a plumbing problem, really. So if we make the blood supply, if we renew the blood supplies as fast as possible to the cell, which all the project that Professor Roth was talking about, will help the recovery of the stroke. We prevent the cells from dying, because otherwise they'll just suffocate. I'm just going to introduce you Winnie here. Winnie Show, Dr. Winnie Show.
Hi, Winnie.
Yeah, so she worked with us on COGWATCH, which I'm going to talk about a bit later, but now she's going to work on a new project that actually much more clinically, and this project is really going to look at all kind of mechanisms to prevent clot, basically, in the brain. So looking at whether we can identify abnormality in the way our heart function in advance to help prevent stroke. So if you want to know more about this project or want to be recruited to it or want to learn about it, you need to speak to Winnie. Okay. So, as I said, if there is a lack of blood supply, what basically happens to the brain is that the cells die. So this is just an image of a brain. Okay, I don't know how many of you are familiar with how an image of the brain look like. So if I just going to briefly orient you, so these will be the eyes. It's just as if we took a brain and we cut it in the middle. Okay, roughly around the height of my eyes. So this is basically where the eyes will be, and this is basically where the back of my head will be. And one of the easiest things to identify that something is wrong is that our brain have two halves that roughly look the same. And if there is a really clear difference between one side and the other side, something is wrong. Okay? And you can see here that there's a really, really big black spot, which basically indicates, oh, you don't see it that well. I see it better on my computer. But there's where the arrow pointing, there's a black spot, which basically indicates that there used to be cells there and they're gone. So whatever function this brain cell did cannot anymore be fulfilled. And that would be the impact of the stroke. But the stroke does not just affect the brain cells, they can also affect connections between brain cells, right? So this is just a map illustrating how everything in the brain is connected to everything else. So in one case that you can have a stroke that affects the actual brain cells where the actual thinking happened, but then the brain cells does not operate by themselves, they operate each other anymore. And that will also have a negative, very victim, but if there is a disconnection between your internal speech and your ability to move your lips, if there's somebody if the stroke just came and cut the wires, you can just not properly utter the words because there's just this disconnection that prevents you from speaking. Even though in your head, you're perfectly well, but it doesn't help. So, many impact, and I think the most obvious impact and the one that gets most funding in stroke is the physical impact. So a lot of people will suffer some kind of hemiparesis or some kind of weakness to the level of degree that they actually lost the ability either to walk or to use their hand or in the face. And for that instance, I'm going to present Dr. Karim, who is another colleague from University of Birmingham. And Dr. basically, one of the things he's working on is developing an automatic system basically which allow you to first map in the virtual reality how far you can move your hand, and also to be able to practice again in a game-like environment the moving of your hand to recover your whole, to try and recover your ability to move your hand in space. So it's both to diagnose your disability actually, but then also to enable a fun environment that you can actually use at home. As Bryn said, that will be the future to help you practice it at home by yourself and to your medic. Okay, but beyond the physical impairment, beyond the things that are very obvious, there are all these cognitive impairment, which is basically the things that happen in the background, which we rarely aware that we actually need them. But if you try to, for example, program a computer to do what we do on a daily basis, you see how complex they are. Even just, if you try to program a computer, for example, just to grab that and lift it, just an impossible task for a computer. And there are so many things in the background of our brain that does it instantly and automatically. So that's what we call cognitive impairment. So what kind of cognitive impairment we have? So you have to think about the brain as really the headquarters of our body. And it's have everything in it. It's really like Westminster Parliament. So the first thing our brain needs to do is you need to receive information from the outside world. And if, for example, so we have these peripheral organs, we have the ears, we have the eyes, we have the hands, so we can feel what's going on outside the world, but all this information is fed into the brain to specific areas in the brain. If the specific area in the brains have been affected by the stroke, you, for example, will lose the ability to see. So if I have a damage to the back of my brain just here, for example, on that side, I would not be able to see what's happening out there in the world, in part of the world. Part of the world will become blind to me. And the same thing with my ears. If I'm losing part of my area just here above my nose, again, I would not be able to hear. So my ears are perfect, my eyes are perfect, but the information that should get this information in the brain is not working, and I will basically practically experience blindness or deafness. Or I could lose my sensory feeling. So depending on the type of information, that could be lost depending on the area of the brain that is affected. If we go a bit higher, I mean, it's one thing to perceive what is out there, but it's another thing to think what actually we can do with these things. So it's not just like I can see, but to be able to see and understand the world, I need to know something about the world. I need to know, to be able to say, this is a person and this is the background, this is the wall, this is a clock, this is a box, this is a computer. Again, this information is stored in the brain. If your area is affected, if the area that is affected is the area that stored that information, you would lose that knowledge. You would see a mug and you have no clue what it is. You just won't know. You can walk, you can talk, but the life doesn't make sense anymore. And it's very difficult. First, it's very confusing. It's very scary. Yeah, it's as if you landed as an alien from somewhere else. And it's very difficult as well to explain to yourself and to your family what's going on. Because they think, what, you're deaf? It's a mug. Yeah? And again, I think I was talking with Brim about self-esteem. It's very easy to lose your self-esteem, to lose your self-confidence, if you don't really understand what's going on, if you don't fully understand. And I think that's where we want to come in and explain to, yes, you lost that area in the brain, that's where you cannot do that. But you're not daft. It's okay, yeah? We can work and help, or we can find way to recover. But it's just this idea to really find and pinpoint where is the problem, because these are problems that you cannot just see by observing a person. Another thing, apart from understanding, we obviously interact with the world. So it's not just about our understanding what we see, it's about how we interact. So, and that could come in many different ways. So obviously speech and writing, but also action, and also knowing what is appropriate or inappropriate. So there is an area of the brain that if you lose it, you lose the ability to know what is appropriate or inappropriate to say. You can start cursing. You can start losing your temper. You can start doing a lot of host of other things, which is totally uncharacteristic, just because you lost the ability to manage and control yourself. You lost the ability to know what is important, what is appropriate in what context. But that is a very high level social, and then obviously in social interaction, which is a very complex environment to work through. Mm-hmm. What do you say to this person? How do you react to this person? So there's a lot of things that we do on a daily basis which we don't think about, but there are dedicated brain regions that do that thinking for us. And if they're gone, we cannot do that. We cannot, we can behave to our daughter as if she's our wife, right? Because we just lost the ability to tell the difference. We lost the ability to make sense or to target action appropriately. Or in the simple case scenario, for example, we can lose our ability to know how to make tea. And a famous professor in Birmingham, Professor Anne Wing, which I'm going to talk about his study soon, said, if you can't make tea, life is not worth living. But you can lose the ability to know how to make tea. You know that it's a mug, you know that it's a tea bag, you know that it's a kettle, but you just don't know how to work them out. You just can't open the kettle. It doesn't matter how many times you try, you cannot get through. And what button exactly you press, and how you position your hand to press the buttons, to press the kettle to fill the water. And what do you do first? You fill the water first, you boil the water first. So all these things is information that is stored in our brain, and we take it for granted. But a stroke affecting these areas means we don't know that anymore. We just don't know. Right. So we've gone to that. So one of the things about stroke is that it's very, very common to have cognitive impairments or cognitive problems. and it has an extremely significant impact on your recovery and rehabilitation. And different types of deficit don't always occur in isolation. So you can be affected by many different things, and it's very, very important to identify what exactly is the problem. So, for example, a person who cannot speak may look to you as if he doesn't know anything, but actually the only problem is that he cannot speak, but he's actually fine in everything else. So one of the things we were trying to do in our trial, or the trial base that was led in Birmingham, is first try and come up with a screen that will be relatively fast and relatively easy to do in the world, that will basically tell us in a snapshot what is the cognitive profile of the person before he starts. And that's basically what Graham was referring to is the BICOS trial, or the BACS trial, which I think ended up in 2010 or 2009 or 2010, something like that. And if any of you know of the OxCare trial, so this is the grandchild of that trial, okay? So the OxCare is just a shorter version of the BICOS. So the BICOS trial was led by Professor Humphreys from the University of Birmingham, and was and one of the major forces, enthusiastic forces, is Dr. Wylene Bickerton. He's going to come to work in Sudwell soon, so you're very lucky. And one of the rationale of the BICOS trial is to try and cover as much as possible functions, cognitive functions that we believe are the core functions of the brain, to be able to identify where exactly is the patient problem. And then if we know exactly where the patient problem, first we can explain it to him, so it would be less scary. We can explain it to his family, again, it would be less scary. Things will start making sense, and once things start making sense, you can start come up with plans of how to deal with it. And also following that, the next step will be obviously to try and develop rehabilitation that specifically targets the patient problem. So that the domain that it covers, basically it covers language domain, which is something that is very common. It covers memory, which is again something a lot of stroke patients complain about, the stroke survivors. It covers attention and executive function, which is a major, major problem following stroke or any acquired brain injury. And action and planning and control. So we collected data from about 900 stroke survivors across the Midland. I don't know if Sandwell was part or not. You were?
I wasn't there.
Right.
I was at
City. City were definitely part. City were definitely part.
Yes.
I remember seeing data from City. So we collected data from about 900 patients, and I think what is unique about this data, and it's slowly, and papers from that study slowly coming out, dripping, because it's one thing to collect data, and it's another thing to analyze it and make sense of it. So now we're in the stage of analyzing and making sense, because it's a lot of data. So the nice thing about the BICOS is that it was very, very inclusive. So basically every person who was admitted to the ward and could focus for more than half an hour would be approached and asked to join. So we got a really good snapshot of the expected cognitive profile of stroke patient. You know, what do we expect? Like, what are the type of cognitive impairment they experience? What are the commonality between cognitive impairments? How rare is a specific impairment? So it's a really amazing database. On top of that, one of the things we do, and that's the part where I'm most involved, is for almost 600 of these patients, we also got permission from the patient to obtain their imaging data. So basically, we went to the hospital and asked to get the clinical imaging data, which is usually a CT, which was, at the time, was the first thing that would be done in hospital to then inform whether you should go through a thrombolysis or not. So we get this imaging data, and one of the things we're trying to do is we're trying to find out, can damage in a specific area be correlated to a damage in a specific function? And I just want to focus on one example. And for that, I'm going to basically tell you about Rachel's study.
Joy.
These were chronic patients years and years after their stroke, which participate in our trials, which we have about 30 of them. So even if you're long-term recovery after stroke, we give you only 5 weekly sessions a day. You do become better at making tea if you work with our system. as opposed to if you do something else. And that's improvement stays with you even half a year later. So there is hope for practicing and training. And I think I'll finish here.
Thank you.